said.
Right. So here's the warm up for today. Nerds.
Matt, you can't get student loan if you die.
That's not true. It just becomes your parents' problem.
It sucks to do that.
Why we should have free education. Alright. Double A, double B. What we are going to do is find all different ways to write this. So one way to write with two A's and two B's at our disposal is to just write a single A. Or to write a single B. Another way that we can write using this stuff would be two A's, right? So you could write two A's. You could also write two B's, couldn't you? Here's how I'm going to organize this to prove that I found all the possible ways. I'm going to say that if I go to the left, I'm adding an A. And if I go to the right, I'm adding a B. What happens if I go to the right from here?
AB.
I get AB. I add a B, right? So I get A, and I get B. Which also, you'll notice, is the same thing as going to the left from here. Oh my God. Did I represent all the possible ways to write with two letters given A and B as options? Yes, I did. I have A and B, I have A and A, I have B and B. All the possible ways. Let's find all the other possible ways. You have a maximum of two A's and two B's to play with, which means at the top here, when we get all the way to the top, should be double A, double B, right? When you use both A's and both B's. Now, fun story. If we go to the right here, because we can't go to the left, right? We don't have another A to mess with. We get AAB, right? Now, I'm going to say that BAA, the reverse of that, is the same thing. I'm not going to write it, okay? However, I am going to say that this is different. Where'd my blue pen go? That BA is different. So I'm going to write that down to include it there. I'm going to do that with all of those. Okay? Notice how BAA is the same thing as AAB, right? So I didn't write it. Fun, excellent, fantastic. That's not your warm-up. That was the practice example. Do you see how that works? Okay? When I fill all of that out, this is what I get. Anise cookies.
You
guys know what those are? Anise is the flavor that makes licorice taste like licorice, and they have cookies that taste like that. So you can go to the store around Christmas time and buy anise cookies.
I like black licorice
I'll get
though.
cheese.
I'm not a big fan of anise cookies.
They're gross.
They are gross. They taste like they sound.
I'll stick with my Cheetos.
Like movie. So there's all the possible combinations, and this guarantees I get all of them. Notice I didn't write BAA because it's the same thing as AAB. Are we cool? Here's your job. Your warm-up is this. Good luck. Work together. You have more options. All right, so 100 points to Gryffindor if you guess the shape. Very good. 100 points to Gryffindor. All right. Why did they call it a triangle? Three angles. Thank you very much. So we have three angles. We're going to call that A, and A. And then we're going to call this S, S, and S.
Zed, once you look at your YouTube comments.
Like and subscribe. All right. So how many A's and S's do we have to play with? 3 each, right? I want you to write all the different combinations of these. So I'm going to say that ASA is the same thing as ASA, right? It's forward and backwards the same thing, right? I'm going to say that AAS is the same thing as SAA. Forward and backwards are the same, right? But I am going to say that ASA is not the same thing as AAS. See how we have 2 A's and 1 S in the middle? 2 A's and 1 S on the side, I'm going to say is different. Just like we were doing before. 2 A's and then a B is different than a B in the middle, right? They're not forward and backwards of each other. Does that make sense? So find all the combinations. What I would do is I would start out with S and A. So here's S. Here's A. That's the first thing you can do, right? We also know that if we do 2 S's, that's possible. We also have 3 S's possible, right? This is how your chart should start out. Make sense? Is there another way to write SA? Sure, AS, but it's the same forward and backwards, right? So who cares? Who cares? Fill out the rest of the chart. Find all the possible combinations. You may begin. Work together.
Hey, I found this big ass Cheeto.
Wait, Marissa, you can do this without saying this. Three angles, three sides. Okay.
Sure, it's like a six. It's
Wait,
like
why
a
the
10 ounce bag. Have a Cheeto
Um,
bar
it's
and
the
a
side.
big ass.
S stands for side, A stands for angle. There we go. There we go. There we go.
Let's
See,
go.
memorization, hard, but when you understand what's going on, it's like, oh, how could it be anything else? Classic example of why memorization should not be the end all be all. Yes? Yes, you may. It's not in here. Alright, song of the day is by Bad Bad Not Good.
Can I borrow that? I'm gonna do this.
The song is Triangles. Get it? Get it?
Kind of.
Good.
Mac.
What?
I got the Cheeto.
That's amazing. Sit down and do something else. Literally anything.
What?
Preferably math. Go, work together. Final combination. I will help you. Off to a great start. You probably want more room.
That's a good start. But there's another way to write SSA with two S's and one A, right? That is forward and backwards. Also, you can just do three S's and one A, right? You're cutting to this quick. You know what I'm saying?
Bruh. Professional tractor, farming fleet. I like this method of finding it because it shows definitively that you found it all, right? It takes every possibility into account. It's a tree.
It was Gloria.
That's pretty good. Now, if we move to the right, so our rule is that we move to the right, we're adding A. If we move to the left, then yes. Okay. See how we added, that's why we move to the left. So then we move to the right. Now I need to ask. Okay, so we added A. If I move to the right again, I've added another. Make sense? Yeah. Talk about that. You know what's going on. So write all the possible combinations. That book's going to lead into our lesson. Hold on. I'll give you one more song to get it done. Riley McKenna, work together and do the rest. Did you do all?
I'm all that I can think of.
Alright, I'll be there in a second.
I don't get the diagram though, like how you're supposed to do it, because then you can't do like SSAA, right?
Yes, you can.
Oh!
If you've done AASS, you've already done it though. Another song by Bad Bad Not Good. Time moves slow. Alright, so. We move to the right. write SSA, but that's the forward and backwards, but I'm fine. Okay? Mark. I don't know. How do you check your work? There's a good way to check your work using this method. Okay, yes. Yeah, it is a very similar problem, right? It's just this one has 3 S's and 3 A's available, whereas this one only has 2 A's. Right? So watch out for that. It's going to be a big. Not bad. Keep going. Not bad. You jumped too many. So when we go to the right, we're adding an A. When we go to the left, we're adding an A. So here, we go to the right, so we should just add one A. So here should be right. See what I'm saying? And going to the left here, adding an S, so we get to add one S. Does that make sense? Now there's another way to write this. So I'm going to write this. Notice this one, there's another way to write it, AS instead of SA, but they're the same word. Same thing here with SSA, so I'm going to write this. There's our 2 bits. You can do more. So whenever we move to the right, we're adding an A. Whenever we move to the left, we're adding an A. So if we move to the right here, we're adding an S. Okay. So we move to the right one here. Right. A lot of these. Be careful with your chart.
Would you just have a thing of chili sitting there?
Yeah. Welcome to Chili's, right? Except it's chili.
Hi, welcome to Chili's.
Mines are dead.
So
Mines are
rude.
Remember you said that? You should write that on the wall. And then quote Natalie. 2019. You're an idiot.
Everybody got them right now.
Absolutely idiot.
I love him so much.
Wow.
I watched them too many times. No, it's not funny. He's good. Oh my god.
Biggest dummy 2019.
I forgot about him. You and Noah together have done. No. I'm not superior. I am putting on chapstick.
Okay. Wow. Wait. Add air to it, or you got it?
In the shower.
You look like a puppy, Aiden. I'm
I
sorry.
found a mugshot that looks exactly like you. A mugshot. The dude got in trouble for theft, but exactly.
Alright, so check it out. Here's our chart. Let's see if you got what I got.
I did not.
Probably not.
No,
It's okay.
You did have to.
So if we move to the right means we add an A. So I'm adding an A to 2 S's, so I get this. Which is the same thing as moving to the left from here, right? Adding 1 S. Now there's another way to write this with the S's on the side and the A in the middle. I'm not going to write 2 S's in the front though and an A in the back. Because it's the same thing forward and backwards, right? So what if I move to the right here? Well, to the right adds an A. So I get something like ASA. But I can also write that another way. What else? How else can I write that? AAS, right? And those are the 2 combinations.
I did this wrong. Oh no, I did. No.
I can also go to the right here and add another A. So I get 3 A's. Remember, our rule is that we have 3 A's and 3 S's to play with. That's it. So we can't keep going and add a 4th A, right? So there's our tree so far. I can go to the right, though, from here and add an A. So what I get is A triple S. Like dang cheek thick, right?
Yeah.
And here I can do S triple A. Notice that if I go to the left, or the right here, it's the same thing, right?
Let's
A, 2 A's and an S becomes 3 A's and an S. Now there's another way I can write both of these. In fact, there's a couple of ways, right? I could write this like this, S-A-S-S, SAS. Yeah, you do. Any other ways to write it? Two S's, an A, and an S is just this backwards, right? So no other ways to write it. Same thing over here. How many ways would you expect to be able to write this one then? If this one we can only write 2 ways, how many ways do you think we could write this one?
Don't ask me, I don't know.
There's 2 ways to write this without repeating. How many ways are there going to be to write this one? 2. Why do you think that, Diana?
Because otherwise it'll repeat.
Yes, this is true. But how do we know without having to check? Just from using this information that this guy had 2, how do we know this will have 2?
It's the same thing with switch.
Exactly. Notice that instead of having an A, we have an S. Instead of having S's, we have A's. It's the same thing. It really is, right? So it's just going to be like this guy, but with the A's and S's switched. Like this. Cool. All right. That becomes that. And then that means these 2 should both agree. What's going to go here? 2 A's and 2 S's, right? We're adding on an A, adding on an S, depending on how you look at it. So 2 A's and 2 S's. How many ways are there going to be to write this one? What other ways can you find? Give me another way to write 2 A's and 2 S's. Yeah, Katie.
S-A-S-A.
Sa-sa. Give me another one. Are there more? Or is it 2 like the sides? I'll tell you right now, there's 2 more ways to write this. Yeah, go ahead.
A-S-A-S.
A-S-A-S would just be this backwards, so we're not going to count it.
Okay.
Yeah, good question.
A-S-S-A.
A-S-S-A, well done. So, capping it with 2 A's, cap. ASA.
Like NASA.
Like NASA, but like booty. The study of booty. We'll put a booty into space by 2020. What's another way? There's another way, yes.
Can you change the one in the corner, S-A-A-A, to A-S-A-A?
A-S-A-A, we already did it.
Oh, oops.
Yep.
Oh.
What about this one?
Oh.
There's no way to write this one. It's okay. It happens. This is all very new. There's one more way to write this.
S-A-A.
Go ahead, Natalie.
That's what I was gonna say.
Okay. Cap it with S, right?
And that's not flipping into the.
Nope, it's not. So these all go together, right? Just like these go together, and these go together, and these go together. Alright, cool. So I can keep moving to the right, because I can keep adding A's. So I have double A, triple S.
Batteries.
I'm running out of room. And I can keep going on and on and on. When you're done, it should look something like this. Let me see if I can. Ooh, I know. I didn't do it in color, but here it is. In green. I didn't write all the possible combinations down. Like for this one, right, we give you double A, double S, right, in that order. But that's the idea. So, the point of this, besides figuring out that, look, trees are useful. When you have 2 options for something, making trees can show you all the possible combinations very easily. When we have 3 things, unfortunately we don't have 3 dimensions here on paper, so it's hard to do. But it is possible with computer software. This is kind of a hint for the chicken nugget problem, by the way. Kind of. Yeah. Kind of. What we're going to do right now, though, is we're going to talk about this. So, triangles congruent? So if I have two triangles, for them to be congruent, it's kind of difficult. Question. These two segments. Stop. We're on a hill for some reason. I don't know why. For these two segments, are they congruent? Yes or no?
No.
Why not? Because what?
They intersect.
They intersect? Okay. Agree or disagree? And if you disagree, you have to say why. And if you agree, you have to say why. Thank you, Macy. She says these are not congruent because they would intersect.
Like congruent means like same size.
Congruent means what?
Good, that's my question.
Yeah.
Now I gotta paper towels.
Yes, you may. It's been a long break, huh? What does it mean to be congruent? It means they're the same, right? And by the same, we mean like same size for segments, because that's all segments have, right? In other words, if we can take one segment and move it on top of the other, and it's the same thing, we call them congruent. We call this superposition, okay? So if two things are able to map on top of each other perfectly, we call them congruent by superposition. So these actually will be congruent, even though they're going at different angles. I think, Macy, what you were thinking is parallel,
Yeah.
right? Mm-hmm. And that's fine. So these are going to be congruent. All segments have their size. They're like Danny Map. They are defined solely by their size. That's all he's got going for him, and it's not much, right? So there you go. Triangles a little bit more complex to prove congruent, though, because there's lots of different things in triangles, right? Turns out there's sides and angles, and there's lots of them. 3 each, right? So what we're going to check is to find out what the maximum or the minimum requirements for a triangle to be congruent would be. So, for instance, if I know a triangle has all 3 sides and all 3 angles the same as another triangle, then they're congruent, right? Everything's the same, then they're congruent. That makes sense. But do we have to check every single angle and every single side to make sure triangles are congruent? That would be really annoying, right? We want to find a shortcut. So here's what I've done. I've made a map. If I check a single angle, is that enough to prove a triangle congruent? If it is, then any of this other information that I'm given, like 2 angles, if I'm given 3 angles, if I'm given 2 angles and a side, if I'm giving an angle and a side, then any of that would be enough to prove it congruent, right? Because a single angle is enough, then a single angle plus more would be enough, right? If I know that 3 sides is enough, then that means anything that gives me 3 sides plus more information would also be enough. So I want to try and find out where I can cut this short so I don't have to check all the sides and all the angles. So let's check it out. If I have a single side, if I tell you that I have 2 triangles and they both have this one side length the same, is that enough to prove that the triangles are the same? So I'm going to say it again. If I've got 2 triangles and all you know is that they share a side length, they both have the same side length, is that enough to prove that both triangles are the same in every other way? Why not?
You only got one measurement.
The reason that's not enough is because the triangle over here can be this triangle, right? And the triangle over here, stop. They are. That's what magnets do. Anyone know Insane Clown Posse?
Who?
We'll have to listen to that song sometime. Magnets. How do they work? Except they don't say that. So look, we have 2 triangles that share the same side length, but are they congruent? No, they're 2 different triangles, right? So one side length is not enough to determine if 2 triangles are congruent, right? I just showed you an example where, look, they have the same side length, but they're not congruent. What about 2 side lengths? What if I know 2 side lengths are the same between the triangles? Like this. All right, I'm not worried about the angle, doesn't matter, right? If I know 2 of the side lengths, is that enough to say that these triangles will be congruent? By counterexample, no, that's not enough. Here's an example where I have 2 side lengths on both triangles that are the same, right? But they are different triangles. So 2 side lengths is not enough information. What about 3 side lengths? If I know 3 side lengths of a given triangle. Like this. connected them yet. But when I do, there's only one way I can connect it. Like that. Anything else, if I try to change the angle a little bit, it's not a triangle anymore, right? Any angle other than these doesn't work. So if I know the three sides, it locks in the angles. So I know all three sides are the same, and I know all three angles are the same, guaranteed. So I know that the triangles are congruent. All I need is to know that the three sides are the same, to know that the triangles are the same in every way. Angles are all the same, sides are all the same. And again, what I'm trying to say here is not that all the sides equal each other, because look, all the sides don't equal each other here. We have a side here that's longer than the other two. But as long as I know that this one has a side that corresponds with this one, and these correspond, meaning they're congruent, then I know that I'll end up having the same triangle. So if I know that this side matches this side, that side matches that side, and that side matches that side, if I have three sides that match, that's enough to prove the triangles are congruent, because it kind of locks in the rest of the angles, right? For a triangle to be congruent, all the sides have to be the same, right? Matching. And all the angles have to be the same. Matching. Be careful when I'm speaking, okay? I'm doing this to save time, otherwise it takes forever to say it. What I'm saying when I say the sides are the same is I'm not saying all the sides equal each other, because they don't, right? This side does not equal that side. What I'm saying is that the corresponding sides, the ones that are in the same relative location, kind of like corresponding angles, right? The sides that are in the same relative location have to be congruent, and they are. The angles in the same relative location, the corresponding angles here, here, and here have to be congruent. These guys are congruent, these guys are congruent, these guys are congruent. So all of the sides are congruent, and all of the corresponding angles are congruent, which means the triangles are congruent. They're the same triangle. So as long as I know all three sides match up in some way, then I know that the angles are going to match up in some way. And if all the sides and the angles match, and all of the sides and the angles match up, then the triangles are the same. So knowing three sides is enough to prove the triangle's congruent. Which means if I know three sides and an angle, well, I've got extra information, but it's still enough to prove it congruent, right? So we don't have to check all three sides and an angle to see if they're congruent. We don't have to measure all three sides and measure one angle to make sure they're congruent. We can stop at three sides. So that's convenient. So three sides is enough. Let's try angles now. So notice before, when I said a side length, I used two dots on the end to show that that's how long I want it. Angles don't have length, right? They can be any length. Here's an angle. And here's the exact same angle but longer. Stop. I know they're the same angle because I'm squeezing these together as much as I possibly can, right? Those angles are the same. The side lengths aren't, but that's okay. Remember, I didn't cap them off with dots, so I'm not really concerned about the length of the sides. I'm just talking about the angle that they make. So, if I've got two triangles, maybe you already know from my example, that have the same angle, is that enough to prove that the remaining parts of the triangle will be congruent? Yes or no? What do you think? If these two angles are the same on each triangle, is that enough to prove the rest of the triangle congruent? Be careful. Why not, Quinn?
Because it would work. Like, I don't know. You need three things to,
You need three things, huh?
yeah.
Let's check it out. A very common response would say, yeah, that's enough, because look, there's only one triangle you can make that has that angle. But remember, we're not worried about the side lengths. I could do this, and it would have the same angle down there where my dot is, right? These are the same angle. But are they the same triangle? No, they're not. So one angle is not enough. Otherwise, that'd be really convenient. We just check one angle. All 93 triangles are the same. Not true, right? What about if we had two angles? What if two angles are the same? So I'm going to squeeze these in as much as I can to make that triangle. If I can make a counterexample with a triangle that has the same angle here and here, but are different side lengths, then I've shown that 2 angles isn't enough to prove it. So I'm going to do this. And to check to see if these are the same angles in the bottom, I'm going to go like this. Is that the same angle? That checks out. That's the same angle. Is this the same angle? Yes. So even though I know 2 of the bottom angles are the same on both triangles, that doesn't mean that the triangles will be congruent. That's not enough information. So double A doesn't work either. That's not enough info. What if I know all 3 angles? I want you to experiment with this. So get out some graph paper. Go now. I gave you a protractor. Get some graph paper. Go. Here's how we're going to check 3 angles and all the rest. All right, so let's go back and redo the double angle thing that I just did. So remember, angles don't have length. So what I'm going to do is I'm going to draw some line, just an arbitrary length. I'm going to go to one endpoint and put the endpoint on my circle. So there's my endpoint. I'm going to put it in that circle on my protractor. You see this line on my protractor? I'm going to put the dot in here and line up my line with this line on the protractor. When I do that, give me an angle measure.
57.
57. How about something a little bit nicer?
55.
50. Thank you. So there's 50. I'll put a dot there.
Wait, how long is it?
Doesn't matter how long it is. It's arbitrary. We're talking about angles only right now. Okay? So I'm going to make a 50-degree angle. The way I do that is I set my protractor on this line, and then I put my dot on 50. So there's 50. So from here to here is 50 degrees. Then I'm going to draw a line. Doesn't matter how long it is, right? I'm just worried about 50 degrees. So that's 50. Then I'm going to go over here. Let's pick another angle. Give me another angle measure. 20. All right, so there's 20. And notice I'm putting it on the 160 because I'm going to the left. So going to the left, that's 20 degrees, right? Does that make sense? Linear pair theorem says that if I go here and put my line for 20, that if I were to measure it not from here, but from here, I would get 160. So that's why it has 160 there as well. Going from here to here, it's 20. Going from here to here, it's 160, right? 2 ways to look at it. Here to here is 20. Here to here is 160. So I made a 20-degree angle right here. If I measured it from here to here, it'd be 160 though. That's why there's a 160 there. Everybody cool with that? All right, awesome. So that makes my triangle. I didn't measure any of the lengths out to anything specific, okay? Now the question is, can I make an arbitrary length with the 50 and 20 and make a different triangle? And if I can, that shows that knowing 2 angles isn't enough. Yeah?
To make the 20-degree angle, you put like the bottom of the protractor on top of the first line you made, right?
Mm-hmm. The right side.
Yeah.
And then I draw my 20-degree angle from there.
Thank you.
Mm-hmm. So I'm going to do the same thing, again with an arbitrary length. I'm going to make my base a lot bigger than this last one, okay? I'm going to do a 50 on the left and a 20 on the right. So 50 on the left is this. And again, I don't care how long these are. Where they intersect is where they intersect. And a 20 on the right. And because I measured it, I know this is 50 and that's 20, just like the triangle above. So they both have the same angles. Are they the same triangle? Are those 2 triangles the same triangle?
I like that thing we're working on, the rotation thing.
Are they the same? Are they congruent? Are all the sides and angles the same? just using two angles making them the same, did I automatically make two triangles that are exactly the same? No, they're different sizes. So I showed by counterexample that just knowing that two angles match isn't enough to prove the triangles are the same, right? I could have a situation where they are different still. Check to see if three angles is enough, because Quinn said we need three things to prove triangles the same. Remember, use arbitrary line lengths, but make sure your angles are correct. Now you'll notice that, well, I'll let you get to it. Try three angles. Try three. Make three angles, connect them together to make a triangle. All three angles in a triangle have to add up to what?
90.
180.
Darn.
Right? 180. So that means when you do your three angles, don't make something that doesn't add up to 180, otherwise you won't have a triangle. You'll figure that out real quick. So see if three angles is enough to prove two triangles congruent. Do you automatically get the same triangle when you have the same three angles? I'll make some angles. That kind of automatically says my last angle, doesn't it? Not even measuring that, I know what that is. Can I make another triangle with those three angles that's different in size? If I can, then triple angle isn't enough to prove that the triangle is. Do a 50. Alright, so on my triangles, hopefully you've done this too, I have three angles that all match up, right? 50 and 50, 60 and 60, 70 and 70. So I know all three angles are the same, right? Is that enough to prove that the triangles are congruent? Are these two triangles the same? No, their angles are the same, but are their sides the same? Remember, everything on a triangle has to be the same for it to be congruent. For line segments, it's really easy to see if they're congruent, because all they have in common, is their length. That's all they got going for them, right? But triangles have a lot more. They've got angles and sides. So all the angles and the sides have to be the same. Are my angles the same? Oh yeah. But are all my sides? No. So I've shown, by contradiction, look, triple angle isn't enough to prove these triangles the same. So triple A isn't enough. We need more information. Triple S was, but triple A isn't. What I want you to do is check the rest of these to see what the minimum number of things required might be to prove something true. Let's check an angle and a side next. So what I'm going to do is I'm going to make a side length of 4 for both my triangles. Because the sides have to be the same, right? We're checking angle side. One side for each triangle has to be the same. Then I need one angle that's the same. So what angle measure do you want me to make? Give me an angle measure. 60. All right, again, this side doesn't matter how long it is. So I'm just going to draw it really long, right? That means this one has to be 60 because their angles have to match, right? We have to have one angle matching and one side match. So here's 60. Now, is it possible to draw two different triangles if I'm forced to have one side match each and one angle match each? Yeah. Check it out. Here's one triangle, right? Here's another triangle. Are they the same? No. So angle side is not enough to prove that they're congruent, right? One angle and one side alone is not enough. When you check the rest of these, angle side isn't enough. Notice that angle, angle, side is different than angle, side, angle. Here's what I mean by that. Angle, angle, side means you have two angles next to each other and then a side after it. That's the same. Angle, side, angle means you have two angles and a side in between that are the same. Those are different and you need to check them separately. Anyone want to check ASS? That would be when you check an angle and then two sides after it. For your homework, you're going to check the rest of these. Don't check them all. For instance, I know anything with 3 S's in it is good, so I don't need to check anything else on my tree that has 3 S's. If I find out that ASA works, then that tells me anything with an A, an S, and an A in that order is also going to be fine. So for instance, ASAS would work too, right? I don't need to check that. That's your homework. Check the rest of these. We're trying to find shortcuts so we don't have to check them all. My advice would be to work together on this. A lot less work to do if you split it up, and hopefully one of you will be able to see what's going on. This is kind of hard.
Was this the warm-up for today, or is this what we're doing for the rest of the week?
This is the warm-up for today, and it's what we're doing today. And then we're going to move on and do a little bit more that sort of has to do with this, but not completely.
I'm so confused on this right now that I can't
All right.
do it at all.
So what we're doing is we're checking, like for two triangles to be the same, they have to have the same sides and same angles, right? So if I have,
My dog looks like, oh my god, my dog is like powerful. I also make about 5,000 TikToks every day. I can't really will. They're all just I'm like, I don't know how you mind I'll see later. So I'm trying to like
right, I'll show you how to use it in a second. These triangles I know are the same, because those angles, and those angles are the same, and these sides, and these sides are the same. So all the sides and angles match up, right? So they're congruent. My question is, do I have to check every single side and every single angle every single time if I want to check if they're the same? No, we found out earlier, if I check just the 3 sides, that's enough. If I check a side, an angle, and a side in that order, see how the angle's in the middle?
Yeah.
That'll be enough as well. So I want you to draw these out and see if you can find a counterexample. Right, if you were able to find an example like this one, see I checked 2 angles, here and here. So where am I? So these 2 guys, they both have the same angle, 50s and 40s, right? 2 angles. But I was able to draw 2 separate triangles that were different sizes based on those angles, which means that's not enough information to prove. Wrestle with it a little bit, don't freak out, okay?
Yo, Mac, we got games school today?
What?
We got games school today?
Today is Monday.
Oh.
Hi. How's it going?
I'm not right. I need to get the schedule figured out.
Come in here and check it out.
I like
What's the question now?
Sundays.
Driver's Ed.
Are you doing stuff for driver's ed now?
Yeah.
Then no. You can ask Bartos, I don't care. But I'm guessing he'll say no. And when he says no, respect his decision.